Hello everyone, my name is Kishan Agarwal. I am from CSCB. Today I am presenting my concept video of chemistry and my topic is copolymerization. So let's begin with our topic. So before going to the topic copolymerization, first of all look at what are polymers. A polymer is a large molecule or a macromolecule which is essential combination of many subunits. The term polymer in Greek means many parts. Polymers can be found all around us, from the strand of our DNA, which is a naturally occurring biopolymer, to polypropylene, which is used throughout the world as plastic. Polymers may be naturally found in plants and animals, which are natural polymers, or may be man-made, that is synthetic polymers. Different polymers have a number of unique physical and chemical properties due to which they find usage in our day-to-day life. So what is polymerization? Polymers are all created by the process of polymerization. So the process of forming polymer is known as polymerization, wherein their constituent elements called monomers are reacted together to form polymer chain, and the whole process is known as polymerization. That is three-dimensional network forming the polymer bonds. The type of polymerization mechanism used depends on the type of functional group attached to the reactant. In the biological context, almost all macromolecules are either completely polymeric or are made up of large polymeric chains. So that means the process of formation of polymers is known as polymerization, and the kind of polymerization is dependent on the type of monomers used or the reactants used, and it depends on the functional group attached to the reactants even. So let us see what are the classifications of polymers. There are different classifications of polymers based on their properties. So if we see the origin or source of polymers, they are classified into three types, which is naturally occurring polymers, synthetic polymers, which is man-made polymer, and the last one is semi-synthetic polymer. Next is structure. Based on structure, they are classified into again three types. They are linear polymers, branched polymers, cross-linked polymers. And based on molecular forces, they are classified into four types: elastomers, fibers, thermoplastics, and thermosetting polymers. Whereas based on synthesis, they are divided into two categories, that is addition polymers and condensation polymers. So let us see in detail. Classification of polymers based on the source of availability. As discussed in the previous slide, there are three types of classifications under this category, that is source of availability. So how they available in the nature, on the basis of that the polymers are classified into three types, namely natural, synthetic, and semi-synthetic polymers. So first of all, natural polymers. They occur naturally and are found in plants and animals. For example, protein, starch, cellulose, and rubber. To add up, we also have biodegradable polymers, which are called biopolymers. Next kind is semi-synthetic polymers. They are derived from naturally occurring polymers and undergo further chemical modification. For example, cellulose nitrate, cellulose acetate, these are all semi-synthetic polymers. Next is synthetic polymers. These are man-made polymers. Synthetic polymers are nothing but man-made polymers. Plastic is the most common and widely used synthetic polymer. It is used in industries and various dairy products, or we can say in every product which we use in our daily life. Plastic plays a very main role. For example, 9166 is a synthetic polymer, and polyester is also a synthetic polymer. Next, classification of polymers based on structure of monomer chain. So based on the structure of the monomer chain, The polymers are classified into three types: linear polymer, branched chain polymer, cross-linked polymers. So let us discuss one by one. So what is linear polymer? The structure of polymer containing long and straight chains fall into this category. For example, PVC, that is polyvinyl chloride, is largely used for making pipes and electric cables, which is also an example of linear polymer. That means it has linear structure. Next is branched chain polymers. So when linear chain polymers form branches, then such polymers are categorized as branched chain polymers. For example, low density polyethylene, LDPE. Next is cross-linked polymers. So they are composed of bifunctional and trifunctional monomers. They have a stronger covalence in comparison to the linear polymers. Mostly bakelite and melamine are examples of these categories. Next, classification of the polymers based on the polymerization which they undergo. That means the process by which they are made. They are also classified into two types: addition polymerization, condensation polymerization. So addition polymerization, when two monomers combine to form a polymer without removal of any byproduct, that is known as addition polymerization. Examples of addition polymerizations are polyethane, Teflon, polyvinyl chloride, that is PVC. Next, condensation polymerization. Condensation polymerization, when two monomers or two reactants combine to form a polymer with giving a byproduct. Especially, mostly the byproduct is water. And the examples of condensation polymerization is nylon 6,6, perylene, polyesters, etc. So next classification of polymers is based on monomers. So they are homomers, heteromers, or copolymers. So homomers, in this type of polymer, a single type of monomer is required. That is, a single type of monomer is present. For example, polythene. Next is heteropolymer or copolymer. It consists of different types of monomer units. That means the monomers are of more than one type. Example is nylon 6,6. Next, classification based on molecular forces. They are classified into four types: elastomers, fibers, thermoplastics, thermosetting polymers. So let us discuss one by one. First of all, what are elastomers? These are rubber-like solids. Weak interaction forces are present. For example, rubber. They are known as elastomers. Next is fibers. Strong, tough, high tensile strength and strong forces of interaction are present. They are known as fibers. For example, nylon 6,6. That is why fibers are used to climb the rope, to make ropes, nylon ropes, etc. Thermoplastic. These have intermediate force of attraction. That is, not too weak and not too strong. Intermediate force of attraction. For example, polyvinyl chloride is the best example of thermoplastic. Next is thermosetting polymers. These polymers greatly improve the material mechanical properties. It provides enhanced chemical and heat resistance. For example, phenolics, melamine, bakelite. These all are the examples of thermosetting plastics. And thermosetting plastics, once they are defined or once the shape is given to the thermosetting plastic, they cannot be remolded or remodified. Whereas thermoplastics can be remolded and reshaped. That means they can be used again and again. That means they can be recycled. Whereas thermosetting plastics do not, or thermosetting polymers do not, cannot be remolded. So just now we have discussed the main topic, that is polymers, how they are classified and on what basis they are classified. Now let us see what is copolymerization, our main topic. Copolymerization is a polymerization reaction in which a mixture of more than one monomeric species is allowed to polymerize and form a copolymer. The copolymer can be made not only by chain growth polymerization but also with step growth polymerization also. It contains multiple units of each monomer used in the same polymeric chain. No loss of small molecules like addition polymerization. For example, a mixture of 1,3 butadiene and styrene can form a copolymer. The reaction is shown here. 1,3 butadiene reacts with styrene to give butadiene styrene copolymer. Here we can see there is no byproduct, so it is a kind of addition polymerization. So let us see what are copolymers. A copolymer is a polymer that is made up of two or more monomers species. Many commercial important polymers are copolymers. Example includes polythene, polyethylene vinyl acetate, PEVA, nitrile rubber, acrylonitrile, butadiene styrene, acrylonitrile butadiene styrene ABS. The process in which a copolymer is formed from multiple species of monomer is known as copolymerization. It is often used to improve or modify certain properties of plastics. A homopolymer is a polymer that is made up of only one type of monomer unit. The difference in the constituent of a copolymer and homopolymer is illustrated below. So here we can see homopolymer and copolymers are shown. Homopolymer contains single, or we can say single kind of monomers, whereas copolymers contains different kind of monomers. So classification of copolymers. What are the different types of linear copolymers? Linear copolymers can be further classified into several categories such as alternating and statistical copolymers. This classification is based on arrangement of monomers on the chain. First, in the first figure you can see alternating copolymer. That means the monomers are arranged alternatively. In the second one, block copolymer. Third is statistical copolymer. That means particular amount of calculated amount of monomers are arranged. The fourth one is sequential copolymer. Next is block copolymers. When more than one homopolymer units are linked together by a covalent bond, the resulting single chain macromolecule is called a block copolymer. The intermediate unit at which the two homopolymer chains are linked is called a junction block. A diblock copolymer contains two homopolymer blocks, whereas a triblock copolymer contains three distinct blocks of homopolymers. An example of such a polymer is acrylonitrile butadiene styrene, commonly referred to as SBS rubber. An illustration describing the structure of a block copolymer, which is made up of the monomers A and B, is provided below. This is block copolymer. Next is statistical copolymer. Statistical copolymers are the polymers in which two or more monomers are arranged in a sequence that follows some statistical rule. Should the mole fraction of a monomer be equal to the probability of finding a residue of that monomer at any point in the chain, the entire polymer is then known as random polymer. These polymers are generally synthesized via the free radical polymerization method. An example of statistical polymer is the rubber made from the copolymer of styrene and butadiene. An illustration describing the structure of statistical polymer is given below. Next is alternating copolymer. Alternating copolymer contains a single main chain with alternating monomers. The formula of an alternating copolymer made up of monomers A and B can be generalized as AB taken n times. Nylon 6 is the best example of alternating copolymer consisting of alternating units of hexamethylene, diamine and adipic acid. An illustration describing the general structure of these polymers is provided. Next is periodic copolymer. These polymers features a repeating sequence in which the monomers are arranged in a single chain. An illustration of the given periodic copolymer made up of monomers A and B. So these polymers are arranged periodically and hence called as periodic copolymers. Let us see what are branched copolymers. As the name suggests, a branched copolymer is a polymer in which the monomers forms a branched structure. Some important types of branched copolymers include star, comb, grafted and brush copolymers. A star copolymer contains several polymeric chains that are attached to the same central core. The two different figures shows the star copolymer, which contains several polymeric chains attached to a single or a central core. Graft copolymers. Branched copolymers featuring differently structured main chains and side chains are known as graft copolymers, and illustrations detailing the structure of a graft copolymer made up of monomers A and B is provided below. So the figure shows a graft copolymer made up of A and B. So let us see what are the differences between copolymer and homopolymer. Definition. By definition, copolymer, when there are two or more types of monomers joining to make a polymer, it is known as copolymer. Whereas homopolymer, when a single type of monomer undergoes polymerization to form a macromolecule, it is a homopolymer. Based on monomer, two types of monomers in copolymer and single type of monomer in homopolymer. Varieties exist such as block copolymers, alternating copolymers as we have discussed, and in homopolymer there is no such varieties. Next, examples of copolymers are common examples include saran, styrene, butadiene rubber, Viton, etc. These are examples of copolymers, whereas common examples of homopolymers are nylon 6, nylon 11, polyethylene, polypropylene, PVC or polyvinyl chloride, polyacrylonitrile, etc. Thank you.